But instead of finding the missing angle in the right triangle, instead of finding the missing side in the right triangle, we're going to find the missing angle in the right triangle. So yesterday we found a missing side. Today we're going to find a missing angle. Yeah. So as a reminder, anytime you're looking for missing information in a right triangle, you're always going to use SOHCAHTOA or the Pythagorean theorem. Today, we're going to be finding missing angles. So since we're finding missing angles, the Pythagorean theorem isn't even an option today because the Pythagorean theorem only helps you with sides. So if you look at the problems today, they all have a theta in them because the angle is what we're actually trying to find. So we're going to start off exactly the same way we did yesterday, where we're going to look at the triangle and we're going to look at the angle that they gave us. Here's the angle. And we're going to write down the name of the two sides that are labeled. So I have this side labeled, and what's the name of that side? Hypotenuse. It doesn't matter. And I've got this side labeled, and what's the name of this side? Adjacent. And then which trig function uses adjacent and hypotenuse? Cos. So I'm going to say cos of theta. Remember, theta is just a 0 with a line through it. So cos of theta equals adjacent over hypotenuse. And what we want to do is we want to get the theta alone, and we want to do that by undoing cos. So this is called inverse, and you guys have dealt with inverses before. Whenever you want to undo multiplication, what do? Divide. And that's the inverse operation for multiplication. It's division. If you ever want to undo subtraction, what do? You add. That's the inverse operation for subtraction. It's addition. So you guys have done something called inverses before. It's just how you undo something. So if you grab your calculator and you look right above the cos button, you can see cos to the -1. Does everyone see that? That's actually cos inverse. That's how you undo a cos. It's kind of like dividing by cos, but not quite. So that's how we're going to undo a cos, all right? Now, if you're solving an equation, and if you were undoing a -7 on the left side, so you added 7 on the left side, you would have to add 7 on the right side also to keep the equation balanced. You guys agree with that? Whenever you deal with an equation, you have to do the same thing on the left side, same thing on the right side. That keeps it balanced. Same thing here. So if I want to get rid of the cos on the left side, I'm going to do cos inverse because that's how we undo a cos. But I can't just do cos inverse on the left side because now I've changed the equation. Whatever change I do, I have to do on both sides. So if I do cos inverse on the left side, I'm going to do cos inverse on the right side as well. Okay? So cos inverse and cos cancel each other out, and I just get the angle, theta. Theta is going to equal cos inverse of, and whenever you type in cos inverse on your calculator, it's always going to say, yes, what do you want me to do the cos inverse of? And it's going to be cos inverse of adjacent over hypotenuse. And once we type that in, it's going to spit out the angle. It's going to tell us what the angle was. So I'm going to come over here to my calculator, and I haven't checked. Mine is in radians, so I'm going to make sure it's in degrees. And then the cos inverse is in blue above the cos button. So to get to cos inverse, I'm going to hit second cos. And then I'm just going to type 11.4 divided by 13. So cos inverse adjacent over hypotenuse, and I get 28 point, and they ask us to do the nearest thousandth on these notes, which is 3 decimal places. So I'm going to say the angle is approximately 28.727 degrees. And that's the missing angle. Okay, let's try the next one. So here is the angle. What is the name of the 13? Hypotenuse, perfect. What is the name of the 7? opposite. And which trig function are we going to use? So, yep, we're going to use so. So we're using sine. Sine of theta is opposite over hypotenuse. And so we have to get rid of sine. How do we get rid of sine? We do sine inverse. Yeah, we do the -1. Sine inverse, okay? So sine inverse and sine cancel each other out. And we get that the angle is sine inverse of opposite over hypotenuse. And so now I'm going to type into my calculator second sine opposite over hypotenuse. So my angle is 32.579 degrees. That's it. All right, for the next one, what is the name of the 9? Adjacent, that's the adjacent side. Okay, what's the name of the 2.6? Opposite. So which trig function are we using? Tan, TOA. So tan theta equals what? 2.6 over 9, opposite over adjacent. And how do I get rid of tan? Tan minus 1. So tan inverse on the left, tan inverse on the right. My tan inverse and my tan cancel each other out. And I get theta is tan inverse of opposite over adjacent. And so in my calculator, I'm going to type second tan opposite over adjacent. And what do I get? 16.113. degrees. Huh? That's all you got to do. Yeah, so the nice thing about today that's different from yesterday is we don't ever have a situation where our variable is on the bottom of a fraction. The variable always ends up in the same place. It's always in a nice place. So that makes these a little bit more consistent than the ones we had yesterday. Okay, I want you to go ahead and find the answer for number 4. It's just like one of the 3 we just did. It's going to be one of them. Mm-hmm. So to do any of them in your calculator, you're just going to hit second and then hit that button. Adjacent is the one that's next to this. So it wouldn't be the hypotenuse here. 12 is the hypotenuse. It wouldn't be across from it. It would be right next to it. Mm-hmm.
So would opposite always be the shortest?
No. Opposite is just whichever one is across from the angle. And it could be the shortest or it could not be the shortest.
So opposite is always the one across, or is adjacent always the one across from?
Adjacent touches the theta.
Or whatever.
Adjacent, the adjacent side and the hypotenuse both touch the theta.
So is there ever a situation where instead of theta there's something else that is still the same case if you're looking for adjacent, if that makes sense?
Say that one more time.
So like instead of well before I even ask that, is there ever a situation where there would be instead of theta something else?
There could be. Sometimes they use X.
Okay, so
They can use any letter they want.
it's still the same case if you're trying to find
Yeah. Yeah. What trig function did you guys use? Sine. Mm-hmm. So we've got opposite and hypotenuse. So sine theta is 7 over 12. And what did you guys type into your calculator? Sine inverse of 7 over 12. Well, I'll take it. Did you get all finished? Yeah. Okay. And we got 35.685. You're going to hold on to the notes because we're going to do some practice with this tomorrow. So all you need to finish... You don't need to stand up, though. We're packing up awfully fast for having 3 whole minutes left. So you've got 3 whole minutes to finish up maybe a couple problems if you need to and turn stuff in. You do not have homework.